Hello students, welcome to the mathematics class of class 6. Today I am going to make you learn the third chapter of mathematics, that is playing with numbers. Playing with numbers means students using numbers in mathematics as well as in our daily life. Let's see how do we use numbers in our daily life. When we wake up early in the morning, we see time. And what represents the time, students? Numbers. When we go to the market, we take some money with us. And from that, we spend some money to purchase something. We also try to save some money. And the calculation of this all is possible with the help of numbers and mathematical operations. Similarly, when we go to the bank, we credit some money, we debit some money. And the transaction of money is only possible with the help of numbers and again with the help of mathematical operation. So today students, I will tell you how do we use mathematical operations and in which sequence with the help of BODMAS rule in an equation. So what is BODMAS rule? B for students, brackets. And brackets are of three types: small bracket, curly bracket, and the biggest one is square bracket. Breaking the brackets in a mathematical equation means performing the operation within the bracket first. That is, whatever the operation will be there in the small brackets, you will solve that first, then after in the curly bracket, and then after in the square bracket. And before the bracket, one more sign we use, that is bar. Bar is something like this, students, one sleeping line, and under this an operation is there with two numbers, and before bracket we first break the bar. Breaking the bar means performing the operation which is under the bar first. Then off is there. Off means simply, students, multiplication. A multiplication sign is hidden behind the off, but we represent multiplication sometimes with off. But we solve this off before the multiplication. D for division, M for multiplication. See students, this is multiplication sign and this is off. Off means multiplication, but we perform off, the operation of off before multiplication. A for addition and S for subtraction. So this is the sequence in which we solve an equation with the help of these mathematical operations. Now students, I am going to explain you few questions from the Learning Check 3.1 from the book. The first question is, find the value of this. 150 minus 30 divided by 5. So students, what we have to do, the first division. According to the BODMAS rule, you can write BODMAS in the rough. So we have to perform the operation of division before performing the operation of subtraction, because subtraction is written here and division here. So students, you will write rest of the things as it is, that is 150 minus as it is, and we'll put the sign of equality here. And students, we will first perform this operation, that is 30 divided by 5. So 5 6 is 30, you will get 6, and then 150 minus 6 will be, students, 144. Let's take one more question of this, students, that is fourth question. 8 into 5 minus 15 divided by 5 plus 7. So students, according to BODMAS rule, we will do the division first, then after the multiplication, and then after the addition, and then the subtraction. And where is the division, students? It is here. So students, we will write rest of the numbers and the operation as it is, and we'll put the sign of equality. 8 into 5 minus 15 divided by 5, students, will be 3 plus 7. Now students, the multiplication you have to do 5 8 ja 40 and you will write rest of the numbers and the operations as it is. Now 40. It is students minus 3 plus 7. So it will be students plus 4 which is equals to 44. Now students, question number 2, first part. 20 minus 10 plus 2 minus 3. 10 plus 2 minus 3 within the common bracket student. So what you have to do, you will write 20 minus as it is and will solve the operations which are given in the common bracket first. And within the bracket students there are two operations. Then you will first do addition and then subtraction according to our BODMAS sequence. So student 10 plus 2 is 12 and what is left students? Minus 3 and you will write minus 3 as it is. Now students 20 minus, what is 12 minus 3 students? 9 and 20 minus 9 is 11. Let's take one more question of this students, that is question number 5. 128 minus a square bracket, that is the biggest bracket, 56 minus within the curly bracket 3 into 5 plus, and within the common bracket students two operations are there. One is minus and other is off. So students, what you have to do, you have to write all the things till here, that is before the common bracket as it is, and you will do first the operations which are given in the bracket, that is in the common bracket. So 128 minus 56 as it is minus curly bracket 3 into 5 as it is plus, now within the common bracket two operations are there, and which operation is before, sorry, means what you have to do first, which operation you have to do the first, that is you have to do off first, and off means students you have to multiply 2 3 ja 6. Now 128 minus 56 minus 3 into 5 as it is, now this is 13. 19 minus 6 is 13. Now the common bracket is removed. Now 56 minus, again two operations are there within the curly bracket students, multiplication and addition. We will first do multiplication because according to the BODMAS rule multiplication comes before addition. So students 3 5 15 plus 13. Now 128 minus 56 minus, this is student 28. See how the brackets are now students. 56 minus 28 is 20. 16 minus 8 is 8, that is 100. Now students, I am going to explain you the next topic, that is factors. What are factors students? Any number which is an exact divisor of a given number is called the factor of that number. What do you mean by exact divisor students? Exact divisor students means that whenever we divide any number by any number, the remainder remains 0. If the remainder remains 0, that number by which we have divided is called the exact divisor of the number. See how students, let's take one example. Suppose there is a number 40 and if we are dividing it by 4. So 40 is the dividend students. We all know. And 4 is the divisor. 4 will be the exact divisor when we divide 40 by 4 and if there remains no remainder. See students, 40 divided by 4. 4 10s are 40. So no remainder is there. So 4 is the exact divisor of 40. You can also write 4 10s are 40. So both the numbers 4 and 10 are the factors of 40. 10 is also the exact divisor of 40, students. You can see 10 4s are 40. You can write it here. 10 into 4 is equals to 40. So both the numbers that is 10 and 4 both are the exact divisors of 40, and you can say both are the factors of 40. Now students, let's take one example, that is 36, and the question is find all the factors of 36. So what you will do, students, you will first divide 36 by 1. You can write 1 into 36 is equals to 36. Now you can divide 36 by 2. So 2 1s are 2 and 2 8 are 16. So both 2 and 18 are the factors of 36. Can you divide it by 3? Yes. 3 1s are 3, 3 2s are 6. That is 3 and 12 both are the factors of 36. Again, you can divide it by 4 into 9 is the 36. And it is not divisible by 5. 6 into 6 is equals to 36. So here 6 are repeating twice. See, 6 into 6. 6 is 2 times. So how you have to count the factors, students? You will make a U like this and you will start counting the factors from here. See, 1, 2, 3, 4, 6. You will write 6 only one time. 9, 12, 18 and 36. From students, from left hand side to right hand side, I have made a U. That means you have to write the factors in increasing order. And when you will write numbers like this in a sequence, then you will automatically get the factors in increasing order by making a U from left to right like this. But don't write any of the factor twice. Okay, students? So how many factors are there of 36? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 factors of 36. Those are 1, 2, 3, 4, 6, 9, 12, 18 and 36. And what is so special about 36, students? That is 1 and 36, that is the number itself, and 1 is the factor of 36. It will happen with the every number, students. If you take any number, suppose 56 or 79 or 89, any of the number, you will find that the number itself, that is 1 and 56, that is 56 and 1 both will be the factor of that. Here 1 into 79, that is 1 is the factor of 79 and the number itself. Here 1 into 89, 1 is the factor of 89 and 89 is the factor of 89, that is a number itself, and 1 will be the factor of any given number. That means there will be no any numbers that does not have any 2 factor. Every number has at least 2 factors. So students, what did we notice here? That 1 is the factor of every number. A number is the factor of itself, isn't it? And there are limited factors of any number. That means 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factors are of 36, and another number will be have 4, 5, 12, 13, 20 and so many factors. That means the number of factors we can count. That means the factors are finite, that are countable. We can count the number of factors. And the next thing, students, is that the factor of any number, that is of suppose 36, is less than the number, or you can say equal to the number. Either all the factors of a number is less than the number, that is all the factors, see here, students, of 36 are less than 36, or one factor is equal to that numbers. So these are the properties of factors. Let's take one more example of this. The number is 125. Let's find the all factors of 125. So students, is it divisible by 1? Yes, I have already told you that 1 and the number itself is the factor of in each case, isn't it? That is 125. Is it divisible by 2? No. By 3? No. By 4? No. By 5 we can divide. 5 2 are 10 and 5 5 are 25. That is 125. Now it will not be divisible by any of the number. So students, we can again make u like this. So what are the factors? 1, 5, 25 and 125. So there are 4 factors: 1, 5, 25 and 125. Let's discuss the next topic, that is multiple. We can obtain the multiple of a number by multiplying it by any of the natural number. See how. If you find, students, suppose the multiple of 31, you will multiply it by any of the natural number, suppose by 7. So you will get 7 1 is 7 and 7 3 is 21. So 217, that is 217 is the multiple of 7 as well as the 31 also. Let's find few more multiples of 31. That is, suppose you have multiplied 31 by 10. So 310 is the multiple of 31 as well as of 10 also, student. In this way you can find the multiple of the any given number. Let's take the questions from the book, students. That is from the Learning Check 3.2. The questions are: write the first five multiples of the following numbers. The first number has been given in the book is 6. First 5 students multiples means what? You have to multiply it by the first 5 natural numbers, that is by 1. What are the first 5 natural number? 1, 2, 3, 4, 5. So you have to multiply 6 with first 5 natural numbers. So these are the first 5 multiples of 6. 6 1 is 6, 6 2 is 12, 6 3 is 18, 6 4 is 24, 6 5 is 30. In this way you can solve the rest of the questions of the Learning Check 3.2. Now students, I am going to explain you the next topic, that is prime numbers. What are prime numbers, students? Any number which has only 2 factors, that is 1 and the number itself, is called the prime number. Suppose, students, a number is 7. So how many factors does the 7 have, students? Only 1 and 7. Can we divide 7 by any number? No. Similarly, students, 11. Can we divide 11 by any number? No. It will be divisible exactly by 1 and the number itself, that is by 11. Similarly, 13, 17, all these numbers have only 2 factors, that is 1 and itself. So the numbers having 2 factors, that is 1 and itself, are known as prime numbers. Now students, what are twin prime numbers? Twin means, students, 2, and twin represents the pair. 2 represents the pair of anything, students. So twin prime numbers can be defined as the pair of numbers with the difference of 2. See, students, suppose 3 and 5, not suppose, but they are the prime numbers, and the difference of 3 and 5 you can check it in the rough, students, is 2. So these are twin prime. That means this pair 3 and 5 makes a twin prime pair. Next, again, students, 5 and 7. This 7 minus 5 again gives 2. So this is also a pair of twin prime. Again, students, 11 and 13. 13 minus 11 is again 2, which is also called the a pair of twin primes. So both are in each and every case are prime numbers. So pair of prime numbers in which the difference is 2 makes the twin prime pair. Now co-prime numbers. What are co-prime numbers, students? A pair of numbers which do not have any common factor other than 1. What do you mean by other than 1, students? Means they have the common factor only 1. See how, students? Suppose there is a number 3 and 4. There is a pair of number 3 and 4. And what are the factors of 3? 1 and 3, and the factors of 4 are 1, 2 and 4. They have only 1 as common factor, so they are co-prime numbers. You can take another example, 5 and 6. Factors of 5 are, students, 1 and 5. The factors of 6 are 1, 2, 3 and 6. They have only 1 as common factor. They also makes co-prime numbers. You can say that all the two consecutive numbers, all the pairs of consecutive numbers makes the co-prime numbers. You can say 2 and 3, 3, 4, 4, 5. These are the two consecutive numbers. The pair of two consecutive numbers makes a co-prime pair. 6, 7 and so on. What are prime triplet, students? A set of 3 prime numbers, you can say a set of 3 successive prime numbers differing by 2 is called a prime triplet. The only example of prime triplet is, students, 3, 5, 7. These 3 are prime numbers. 3 is a prime number, 5 is a prime number and 7 is a prime number. And all these 3 are successive prime numbers. There is no another prime number in between 3 and 5 and 5 and 7. So all these 3 are successive 3 prime numbers, and the difference between each consecutive prime number is 3. That is 5 minus 3 is 2. 7 minus 5 is 2. So the difference between each prime number, each consecutive prime number, you can say is 2. So this is the only example of prime triplet. Now composite numbers. What are composite numbers, student? Any number which has more than 2 factors is called a composite number. Let's take few examples, students. Suppose, students, 38. And how many factors are there, students? I have told you that how to find the factors. 1 into 38 is 38. 2 into 19 is 38. It is not divisible by 3. Is it divisible by 4? No. By 5? No. 6, 7, 8, 9, 10. Now it is not divisible by any of the number. So the factors of 38 are 1, 2, 19 and 38. It has 4 factors. So 38 is a composite number. Few more examples are there, students. Suppose 26. Write all the factors of 26. 1 into 26. 2 into 13. 26. It is divisible by 4, no. 5, 6, 7, no, not by any other number. So again it has only 4 factors, that is 1, 2, 3, 4. So all the numbers which have more than 2 factors are called composite numbers. Now students, I am going to make you explain a method to find prime or composite numbers. What is that method, students? Sieve of Eratosthenes method. Who was Sieve? Sieve was a Greek mathematician who gave this method to find the prime or composite numbers. Let's see what this method is. Students, first of all, cross out 1 because 1 is neither prime nor composite. Our Definition of prime number says that it must have two factors, at least two factors, 1 and the number itself, but 1 has only one factor, and the definition of composite number says that there must be more than two factors. So 1 is neither prime nor composite. And what is 2, students? 2 is a prime number. Let's encircle this prime number and single cut out the multiples of 2. 2 2 ja 4, 2 3 ja 6, 2 4 ja 8, 2 5 ja 10, 2 6 ja 12, 2 7 ja 14, 2 8 ja 16, 2 9 ja 18, 2 10 ja 20, 2 11 ja to 12 ja, and so on. Students, you can cut all the even numbers because all the even numbers are divisible by 2. I have written till 60. You can write till 100 or more than 100. Now, which is the another number, student, which is not crossed out? That is 3. Now, encircle the 3 and make a single cut to the multiples of 3. 3 3 ja 9, 3 5 ja 15, 3 7 ja 21, students, 3 9 ja 27, 33 ja 39, 45 will be divisible by 3. Any other number, students? No. Yes, 57 is also divisible by 3. So, what is the next number, students? 5, which is not crossed out. That is 5. Now, encircle the 5 and cross out all the multiples of 5. So, 25, 35, 45 is already cut down, and 1 is 55. What is left, students, here? 7. Now encircle the 7 and cross out the multiples of 7. 7 to the 14, 21, 28, 7 by 35, 7 6 is 42, 49. You can, and no other number is there, I think. 7 9 is 66. Okay. Now, what is the next number? 11. Encircle the 11 and cross out all the multiples of 11. 11 2 is 22, 33, 44, 55 are already cut out. Now, 13. Cross out the multiples of 13, students. So, let's do 13 to the 26. 39 is already cut out. 52 is already cut out. No other number is there. Now, similarly, 17, 34, 51. No other number. Similarly, you can do with another number, that is encircle the 19 and cross out the multiples of 19. Encircle the 23, cross out the multiples of 23. Encircle the 29 and cross out the multiples of the 29. Encircle 31 and cross out the multiples of 31. Encircle 37 and cross out all the multiples of 37. You will find that what you have done, you have encircled all the prime numbers and make a single cut to the composite numbers. Isn't it, students? This is also one of the. Okay. Now let's do few questions from the learning check 3.3. Express each of the numbers as the sum of two odd prime numbers. The number is, students, 36. And how you have to express the sum of odd prime number. What do you mean by odd prime number, students? The number must be odd as well as prime also. So students, if we break this number in 13 plus 23, the sum will be 36. 3 plus 3 is 6. 1 plus 2 is 36. So 13 is an odd number and 23 is also an odd number. 13 is a prime number and 23 also a prime number. So both the numbers are odd as well as prime. The next question is, students, you have to express this 84 as the sum of twin prime numbers. So students, what do you mean by twin prime numbers? It is a pair of two prime numbers whose difference is 2. I have already explained you about the twin prime numbers. So students, you can write 41 plus 43. The sum is 84 and both are the twin prime pairs. See students, the difference between 43 and 41 is 2, and 41 is prime number and 43 is prime number because both the numbers don't have the factors more than 2.